Okay, so we are done with the prerequisites. Now, as a next step, we will create multiple certificates. So as we all know, like Kubernetes is a platform as a service category product, which has many components, which provides various different functionalities to the Kubernetes cluster. For example, there is a component Kubernetes API, a component for Kubernetes controller, etcd. They all have different functionalities. They have an individual role to play inside the Kubernetes cluster, and they often need to talk to each other. Okay, and for to establish that communication internally, they use of certificates. So they use certificates to authorize each other when they are talking. So in this section, we will provide those certificates. So as a first step, let's procure a certificate authority that can be used to generate additional TLS certificate for this cluster. So these steps includes creating a CA certificate, generating a certificate signing request, CSR from that certificate request, and then used to create that signing request to create a public key. Okay, and we can use this step on the any node which has OpenSSL utility. But as I'm using my master one node as in probe master, so I'm going to execute all these commands on my master one. First command to generate the ca.key file. I'm just hitting enter and it is taking all the default values. Okay, and just to avoid any permission issues using OpenSSL, so we have to execute this command. Okay, and now we are going to create a CSR using the private key which we generated from the first command. So this will be the command where we are providing ca.key as an input, and we are expecting ca.csr, that means certificate signing request, as an output. There we go. We can do a ls and we can see we have a ca.csr generated. Great. So now we can use the CSR file to generate a private key. So for that, we will use this OpenSSL command. Here we are providing that key and that CSR, ca.csr, ca.key as an input, and we are expecting a ca.cert, that is a certificate private key, as an output. We can do a ls and we can see we got the ca.cert generated. Okay. So next, in the next step, we will generate client and server certificate for each Kubernetes component one by one, and a client certificate for the Kubernetes admin user. So Kubernetes admin user is a cluster level administrator which has all the super rights to modify any configuration inside the Kubernetes cluster. So for that, we are going to create that admin user certificates. Okay, so what will be the command to generate the admin client certificate and private key? We'll again use this OpenSSL command as an input. So this will be the command. We are expecting a key pair admin.key, and the bit value is 2048. I just hit the enter and it took all the default values and generated that certificate pair. Again, I need to create a CSR for admin user, and I will provide this key as an input and expect admin.csr as an output. This will be the command. Here I'm providing admin.key as an input and expecting admin.csr as an output. Now we got the admin.csr. already certificate signing request generated. And now we will use these two files to generate a certificate for admin user using our CS server's private key. And this will be the command. Here we are using admin.csr as an input, ca.cert as an input, ca.key as an input, and I'm generating admin.cert as an output. We got that generated. So this admin certificate, as we spoke earlier, will be used to perform administrative tasks in our Kubernetes cluster. And while we are using the kubectl command line utility, that will also use the same set of certificate to perform the administrative task inside the Kubernetes cluster. So as a next step, we will generate the set of certificate for next component, which is kube controller manager. So steps will remain the same. We will generate one key file using this command. It take all the default values. There is no additional input we need to provide. We'll generate a CSR using this key file, and this will be the command. And we'll generate the certificate. And we are providing the days expiry days is 1000 days because it's being generated by our own CA. So we can specify till how much time we want our certificates to be valid. So I can see like we got kube controller manager.cert generated. Let's do a lsl command and it'll say if it is generated or not. Kube controller manager.cert crt is the certificate file. Okay, we do have that certificate generated. So we are done with the kube controller manager client certificates. Now let's move ahead and generate same set of certificate for another component, which is the kube proxy. And steps remains the same, exactly same. So I'm executing all three commands in a one go. If you wanted to explore these commands individually, you can just pause this video and refer those commands. So this is the command, and our expectation is kubeproxy.cert should be generated. So let's do ls, and we can see kubeproxy.crt is getting generated. Yeah, that's fine. Okay, so now we have set of certificates ready for controller manager component, kube proxy component, and now let's move ahead and we'll generate the same set of certificate for the next component, which is kube scheduler, which is used for scheduling task. And the steps remains the same. We are generating a key first. We are generating the CSR as a second step, and we are providing all those commands output as an input for the third command and generating this kube scheduler.certificate file. Cool. So these are the components: kube scheduler, kube proxy, and controller manager. We have generated those certificate. But the next component is the most important component inside the Kubernetes cluster, which is the kube API server. And this has been used by many different components very frequently inside the Kubernetes cluster, and we have to specify number of IP addresses because it depends how many masters we are running with, and multiple master node. Like here we are using two node master cluster, so we have the same set of services running on two different nodes, master 1 and master 2. And API is a component which is runs with the master on the only on the master node. And OpenSSL does not have any functionality to provide the subject alternative names as an input. So we have to first create a configuration file for OpenSSL and then use that configuration file in the command to generate the certificates for Cube API so that certificate includes subject alternative names. We will see. So we can see that this is the section where we have to provide subject alternative names, and these are the names and IP addresses we have to provide in this configuration file. So this ls, let's see if this file is being generated or not. Yeah, we do have this file generated, and now we can use this configuration file and generate certificates for Cube API server. And same set of commands, we are generating a key. Second option, we are generating a CSR, and then using all those parameters to the third command to generating the certificates. So now we do have Kubernetes certificate generated for API service as well, which called kube API server.crt. Cool. And let's move forward and generate the certificates for etcd component. So as etcd also is running on multiple nodes, master 1 and master 2. The same steps we need to follow. We need to generate one configuration file which called openssl etcd.conf, just to provide all those subject alternative names we have to provide. Hit enter. Okay, and then just use the same set of commands to generate the etcd certificates. Okay, so the Kubernetes control manager uses a key pair to generate the sign account token as described in the managing service account Kubernetes documentation, which means like Kubernetes controller manager has some dependency of service account tokens, and for that we need to generate service account certificates as well. So same thing, we just need to generate a set of certificate using our same CA, and we'll generate a certificate pair for service accounts, which is required by controller manager component. Okay, so we got those certificates generated. What we have to do is we have to transfer those certificates to the all the master. Like we can have two masters cluster, three masters cluster, or seven master clusters based upon the requirement, right? So we need to copy all those required file. Few components are running in master node, few components are running dedicatedly on the worker nodes. So accordingly, we have to transfer these generated files to appropriate nodes. For example, I'm just creating a for loop and transferring all the required files to my master 1 and master 2 because I have two masters cluster in this setup. So this will be the command. So I'm creating a for loop and you copying this file into master 1 and master 2, and what I'm doing is doing a secure copy, and these are the files, key files, certificate files I'm transferring to master 1 and master 2. And as I do have configured a passwordless SSH, it is not asking for any credentials, and you can see like it already copied all those files to these nodes. Great. Let's move to the next step.